Okay, game theory. First thing you've got to get a concept of is what a zero-sum two-player game is. So a zero-sum two-player game. A zero-sum means no money, if we think in terms of money, comes from outside. Somebody's profit is somebody's loss. You're just shifting stuff around. You're not getting anything else in from outside. So if Lewis and James are playing a game, there's a fixed amount of money on the table already, and that fixed amount never changes. It might move from James to Lewis and the other way around. Two-player game is fairly obvious what that is. A classic example is rock, paper, scissors, where it's a two-person game, and if somebody wins, somebody loses. So the key thing is one person's gain is another person's loss. What I want to go through now is an example, which we'll call example number 1, because it's the first one we're doing. And it'll be about two laptop companies, Company X and Company Y, who are competing against each other. Company X is introducing a new model of laptop, and they want to increase their market share. So X's aim is to increase their market share. And we're going to assume in this that there are only two companies, A and B. There are no other companies, it's just A and B. So if A increases its market share, so if X does rather, it'll just take that market share from Y, and vice versa. So any gain in market share for X will be a loss for Y. Y, on the other hand, what will Y want to do in terms of X's market share? Yeah. Y's aim will be to decrease X's share of the market. And we're looking at this in terms of X. Each competitor is going to have 3 plans of actions. We're going to call those things strategies. So each player has 3 strategies, and we have this payoff table. We have 3 strategies for Y, and we have 3 strategies for X. X's always go down the left. This is going to be called a payoff matrix. And X will be called the offensive player. And the offensive player, the player on the offensive, is always put on the left-hand side. So, we have 9 numbers to go in here now. Across the top row, it's 9, 7 and 2. And you'll all need the matrix written down, even if you're not doing full notes, I think. So if we can get the matrix copied down at least. Strategy 2 for player X is 8, so 11, 8 and 4, and 3 it's 4, 1 and -7. The matrix always shows the gain to the offensive player. So these are gains to player X. So they are also losses for player Y. So these are gains to X. They are losses to Y. The other thing that is a little bit strange and may not think happens in real life is we assume that X and Y both have full knowledge of this matrix. If I can spell full knowledge today. So we're assuming X and Y both have full knowledge of this matrix. And then we just need to make sure we know what this matrix means. So this 11 down here, Lewis, what does this 11 mean? When will that 11 happen? What does that 11 there mean?
When X plays X2 and Y plays Y1, X will have a gain of 11.
Yeah, that's right. If player X plays strategy 2, player Y plays strategy 1, that will result in a gain of 11 to player X. Chris, what does this -7 over here mean?
It means that X will lose 7 and Y will win 7.
In which scenario? Under what scenario will that happen?
Oh, if X plays 3 and Y plays 3.
Yeah, that's right. Okay, so that's what happens first of all. So the aim in all of this is for each player to choose a strategy that will result in their best payoff, regardless of what the opponent does. Because X can choose which of these 3 X strategies he plays, but X cannot control which strategy Y plays. So X is trying to choose a strategy that results in the best possible result for X. regardless of what y does. So each player is going for their own optimal strategy. If each player chooses one strategy, for example, if player X chose strategy 2 and player Y chose strategy 3, if they go with that strategy and they stick with that, that is called a pure strategy. If they don't change their mind, they just stick with what that was. That's called a pure strategy. And the numbers in here are sometimes called the value. So, for example, if player X chose strategy 2 and player Y chose strategy 3, the value of this game, which is a pure strategy game, would be 4. So pure strategy game if they stick with it, and the value would be 4 2x. We happy with those definitions and things so far? Okay, right, so we're moving on to example 2 at this point. So, example number 2, we've got a different payoff matrix now. So if we can copy this one down, we're going to work through this one and get some sort of analysis of it done. So, we've got 3 strategies, 2 players, and these are the values 2x. Remember, x is trying to get the best result for himself, no matter what y is doing. If player X chose strategy 1, his gains would be either 8, 12 or 9, dependent on what player Y did, and X has no control over that. But X will know his gains will either be 8, 12 or 9. If X chooses strategy 2, X knows his gains will either be 13, 9 or 8. If X chooses strategy 3, X knows his gains will be either 11, 14 or 10. X is trying to make his life as good as possible. What he really wants to do is to try and make sure nothing really, really bad happens to him. So what we do first of all, we work out for each row the row minimum. The minimum that X can get, the worst case scenario for X, if he plays strategy 1, is going to be 8. The worst off X will be, if he plays strategy 2, will be 8. The worst off X will be if he plays strategy 3, will be 10. So if you're a player X, which of those strategies would you prefer to do? Yeah. So what you look for then is the maximum of your row minimums. Okay. So what you've got here is a maxi-min strategy. You are trying to maximise your minimum gain. It's like playing safe. Y, on the other hand, will want to do the opposite. Y is looking to make X's gains as small as possible. And what we do the row minimum over here. What we do now along the bottom is we have the... Sorry, that's not a row, that's a column, isn't it, over there? So that's a column minimum. What we have over here is a... Oh yes, it's across the row, you're quite right. Listen to myself to start with, thank you. Yeah, the minimum of each row. Now we're going down each column and we're going to choose the maximum in each column. The maximum of 8, 13 and 11 is 13. That would be very bad for Y. That's a loss of 13. The maximum here is 14. That would be even worse for Y. The maximum over here is 10. So Y is looking, once you've done the column maximums, is looking for the minimum. So Y is doing a mini-max strategy. And if it so happens that player X, the best thing for him to do is play strategy 3, and Y, the best thing for him to do, and they meet here, and if these have the same values, then that has a special name, and that's called a saddle point. That 10 there is a saddle point for this matrix. They will both try and do something, and it's both the best for both of them. They sort of coincide there. The saddle points happen if the maximum of the minimum rows and the minimum of the maximum ones coincide, have the same value. If there's a 10 here and a 10 there, if those numbers are the same, you have these saddle points. And that 10 is called the value of the game. So the value of that game is 10.